In this lecture, we will study the Laplace transform of a monomial function. Before going to start, what is the Laplace transform of a monomial function? We should know what is a monomial function, or you can say what is a monomial. Whenever you have one term, for instance, if you have t square, t cube, and so on, tn, these all terms are called monomial because they all have only one term, so that's why they are called monomials. Similarly, you can say 2t raised to the power 5, this is also a monomial. 4t9, this is also a monomial. So monomial means only one term. So we will find the Laplace transform of these type of functions. Let's start with a very basic monomial. The first one is t. So according to the definition of Laplace transform, we will have this. The function f of t, here is t, so we will replace t instead of f of t, and we can use limit to solve the integral. This integral is an improper integral. Now there are two functions. Whenever you have two functions, so there are so many methods to solve the integral of two functions, but we have to decide which method will be used here. So we will use the method of integration by parts. So first function as it is, integration of the second function. And we will use the upper and lower limit here, minus integral from 0 to tau, and we will replace e raised to the power minus st divided by minus s and the differentiation of the first function. This is the method of integration by parts. Now we will replace the upper and lower limit here. Tau dot e raised to the power minus s tau minus e raised to the power 0.0 over minus s. This is and minus s plus, and this minus and this minus will become plus, and 1 over s over here, so 0 to tau e raised to the power minus s t dt. Now, so further simplification, this will be tau dot e raised to the power minus s tau over minus s, and the second term will be 1 over s limit tau from 1 to infinity, tau from t, limit from tau from infinity 0 to tau e raised to the power minus st dt. Now here are two parts of this transform. This part will call A and this part will call B. So first we will solve part A. So for A, limit tau approaches to infinity, we have tau over minus s e raised to the power s tau. Being a student of calculus, we must know what is a L'Hopital rule and what are the indeterminate forms in calculus. Indeterminate forms, there are so many indeterminate forms. So here we have a form like this, infinity by infinity. This is an indeterminate form. Whenever you have an indeterminate form in limits, you always use the L'Hopital rule. So we will use the L'Hopital rule here and differentiate the numerator with respect to tau, and similarly the denominator with respect to tau. And then we will use the limit, and after inserting the limit we will get 1 over infinity, and finally we will get the answer 0. So for this particular case, for part A, the answer of this overall expression is 0. So we only left B. Now we will solve B. Now for B, 1 over s limit tau approaches to infinity 0 to tau e raised to the power minus st dt. So integrate this factor, we will get e raised to the power minus s tau over minus s 0 to tau, and 1 over s is out of the limit. So 1 over s limit tau approaches to infinity, the upper limit will be minus s tau e raised to the power 0 divided by minus s. After inserting the limit, we have e raised to the power minus infinity 1 over minus s, and further simplification will give this answer 1 over s square. So what it reflects, it shows the Laplace transform of tau is t, as this is a monomial. Laplace transform of t will be 1 over s square, and before that we have studied the Laplace transform of Laplace transform of 1. Keep in mind, you can write 1 as t raised to the power 0, and the answer was 1 over s. If you make a list For this particular monomial case, Laplace transform of 1 means Laplace transform of 0, that is 1 over s, and similarly we have found Laplace transform of t, that is 1 over s square. Similarly, continuing in this way, we will find the Laplace transform of t square. This will be our next task, and continuing in this way, we will deduce the Laplace transform of t raised to the power n in the further upcoming examples.